Accelerating charge. A proton is accelerated from rest by potential difference, change in voltage, of 7,500 volts in a uniform electric field. The potential difference is applied over a distance of 18 centimeters. What is the maximum kinetic energy of the proton? What is its maximum speed? What is the electric field strength? What is the acceleration of the proton? It's the title of the problem here. And how long will it take for the proton to travel the 18 centimeters through the electric field? What's the maximum kinetic energy of the proton? Put all our givens here in a nice, neat place. And this is the charge on a proton, also the charge on an electron, as long as you put a negative sign there. And here's the mass of the proton. Use our work energy equation. Initial energy plus work is equal to final energy. We have the potential energy being converted into kinetic energy. Here's our potential, Q delta V. Here's our kinetic energy. So we have kinetic energy is Q delta V. We're using the conservation of energy, where the proton initially just has electric potential energy. After it is accelerated through the electric field, all it has is kinetic energy. There's no outside work done on the proton. So here's our work guy. That's why we got rid of him pretty quick. So kinetic energy is Q delta V. Here's our Q. Here's our delta V. And the kinetic energy is 1.2 times 10 to the minus 15th joules. What's the maximum speed of the proton? Well, we already found its kinetic energy, which is 1/2 mv squared. We solve that for v, multiply through by, let's see, 2 over m on both sides, and then take the square root of both sides. And you get velocity is a square root of 2ke over m. Here's our kinetic energy from the previous slide. Here's the mass of the proton. And we get a velocity of 1.20 times 10 to the 6 meters per second. What is the electric field strength? One of my favorite equations, delta V equals ed. Solve for E and you get delta V over D. Put the potential difference here. Here's the distance. Notice it's 0.18 meters. We were told 18 centimeters, so you got to move the decimal 2 to the left. And we'll get 41,700 volts per meter. And also, we just found out that the unit for electric field, we initially introduced it as newtons per coulomb, right? Because E was equal to force over charge, so that's newtons over coulomb. It's also equal to volts per meter. Kinematics time. We want to find the acceleration of the proton. Well, we're at rest, so V0 is equal to 0. We have the final velocity that we calculated, and we're going to say we start at x0 equals 0, and then we traveled 18 centimeters or 0.18 meters. There's no time here, so third kinematics equation comes in. This is 0, this is 0. We have 2a delta x. Acceleration then, divide both sides by 2x, and we get the acceleration is v squared over 2x. Put in v, square it, divide by 2 times x. And we get the acceleration is 4 times 10 to the 12th meters per second squared. Now, instead of kinematics, let's use dynamics. Showing off a little bit here. So we're going to start with Newton's second law like we always do. Sum of the forces is ma. So acceleration is the sum of the forces divided by m. The only force acting here is the electric force. So the acceleration is QE over m. Here's Q. Here's the electric field that we found out. And what else? Here's the mass of the proton that other people found out. You do the numbers, and the acceleration, of course, comes out to be exactly the same. 4 times 10 to the 12th meters per second squared. How long will it take for the proton to travel the 18 centimeters through the electric field? Well, now we're doing kinematics, and it asks for how long. So we know we have to use either the first or second. And since we have a distance, a kinematics equation that is, we're going to use the second kinematics equation. We have two initial variables that are 0, which is nice because that allows us to get rid of these two. And x is just going to be 1/2 at squared, but we want to solve for time. So over here, we multiply both sides by 2 over a, right? Yeah, that'll work. 2 over a. So that'll give us here 2x over a, and here the 2 will cancel, the a will cancel, and we have t squared is 2x over a. Take the square root of both sides. T is the square root of 2x over a. Plug in our numbers. And of course, let's see, we said 18 centimeters. Well, that's 0.18 meter. Got to be in meters. And we get time is 3 times 10 to the minus 7th seconds.